language. In your homework that was due before class today, you watched two review videos in your online textbook. They were about writing equations, and your feedback in Canvas told me that that went very well. You understood those videos and you were able to solve the problems that went along with them. And then you also completed a problem set in Big Ideas Math, problem set 6.1. And you also told me in Canvas that that went very well. And always remember that in Canvas, I have posted a solution set where I talk you through each of the problems in your homework. So if you don't get the correct answer when you type your answer into Big Ideas Math and have it checked, if it comes out wrong and you're not sure why, go into Canvas and watch the solution set that I've provided, and then you should be able to find your mistake and correct it. And if you can't, you also can let me know I need help with number 4. And if you send me that in an email, I will get back to you before our next class and we can go over that together. Right? So your homework went really well. And today we're going to move on from writing equations to solving equations. And you know that when we have an equation, it is balanced. The two sides of the equation are equal to each other. So we're going to compare an equation to a scale today, right? So if this scale is balanced, what does that mean, right? This scale is flat, right? One side isn't tipped up or tipped down. So this scale being balanced means that the two sides are equal. Right? I have two blue squares and a red ball on this side. I have two blue squares and a red ball on this side. So just like this scale is balanced, an equation has to be balanced, right? So if I have 2 plus 1 equals 3, it's balanced. 2 plus 1 is 3. 3 equals 3. Right? Just like this red ball and two blue blocks weighs the same as this red ball and two blue blocks. All right. What if I add one side, if I add weight to one side of this balance scale? Let's say I add a green triangle to this side. Well, is my scale balanced still? No, it's not. This side is now heavier, right? So my scale's going to tip a little bit. This side's heavier, so just like a seesaw or a teeter-totter, this side's going to go down a little bit, showing that this side weighs more than this side, right? But if I wanted to stay balanced, think about what I could do. I added a green triangle on this side, right? So that my scale stays balanced, I can add a green triangle on this side. And now my scale is back in balance. Both sides weigh the same, right? Just like if you were sitting on a teeter-totter with your friend, or you might call it a teeter-totter, you might call it a seesaw. If you were sitting on one side and they were sitting on the other side and you weigh the same, well, it's not going to go up or down, right? But then if another friend comes to your side of the teeter-totter here and they sit down, well, now your side's heavier, right? So what's going to happen to this friend over here? Well, they're going to go up, right? Because your side weighs more. Your teeter-totter isn't balanced anymore. And the same is true for equations, right? And the same is true if we subtract from one side of the equation here. If I were to take away this red ball, right? If I remove this red ball from this side of the scale, right? I remove this red ball, well, my scale isn't balanced anymore, right? This side weighs more, so my scale's going to tip now, right? This side weighs more, it's going to go down, and this side's going to go up. My equation or my scale isn't going to be imbalanced, but if I want it to stay balanced, I can do the same thing to the other side. I can subtract the same amount of weight from the right side. So I'm going to subtract this red ball And now my equation is balanced, right? Both sides weigh the same. My scale is flat here because both sides are balanced, right? And this is actually how we're going to solve an equation. Every equation starts out in balance, right? So if you take something away from one side, you have to take away the exact same amount from the other side of the equal sign because your equation has to stay balanced. If you add something to one side of the equation, you have to add the exact same thing to the other side. So on this scale, I have n plus 6 on one side, and I have 10 on the other side, right? They are equal. These sides each weigh the same. Well, I want to know what n weighs. Whoops, sorry. I want to know what n is. So I'm going to subtract 6 from the left side of the scale, right? And when I subtract 6 from the left side of the scale, I have to do the same thing to the right so that my equation stays in balance. If I only subtracted 6 from the left side, well, now the left side weighs less, so my scale's going to be tipped like this. So I had to subtract from both sides. And when I subtract 6 from both sides, on the left, all I have is n, right? Because 6 minus 6 is 0. N plus 6 minus 6 is n, right? 6 minus 6 is 0. On the right, 10 minus 6 is 4. So what this tells me is that n equals 4. And now I can check, is 4 plus 6 equal to 10? Yes. So I know I solved this correctly, right? This equation tells us that 6 is the same as x minus 3. So we have 6 on the left side of the scale, and we have x minus 3 on the right side of the scale. We want to know what x is, but right now 3 is being subtracted from x. So to get rid of that subtraction, we're going to add 3. We have to add 3 to both sides. Any number and its opposite are equal to 0. So x minus 3 plus 3 is just x. 6 plus 3 is 9. So 9 and x are equal to each other. Our scale is balanced. X equals 9. Right? And we can check this. Is 6 equal to x is 9? 9 minus 3? Yes, 9 minus 3 is 6. 6 equals 6, right? Okay, what we've just done there is called the addition property of equality and the subtraction property of equality, right? The addition property of equality tells us that when you add the same number to each side of an equation, the two sides remain equal. And the subtraction property of equality tells us that when you subtract the same number from each side of an equation, the two sides remain equal. So what we just did to balance those scales by doing the same thing to both sides, we have a term for that in math. It's called the addition property of equality and the subtraction property of equality. That if we add something to one side of the scale, we have to add it to the other side of the scale, and our equation will stay in balance. So just like 8 is the same as 8, 8 equals 8, if we add 5 to both sides, 8 plus 5 is 13, 8 plus 5 is 13. 13 is the same as 13. Well, here we have x minus 4 equals 5. We added 4 to both sides. X minus 4 plus 4 is just x, right? Any number and its opposite equals 0. 5 plus 4 is 9. So we have solved that x equals 9. And the same is true with subtraction. If we have 8 equals 8 and we take 5 away from both sides, 3 equals 3. If we have x plus 4 equals 5 and we take 4 away from both sides, x plus 4 minus 4 is just x, and 5 minus 4 is 1. So the statement here, the equation x equals 1, is true. Right? So we're going to try to apply this to several problems here in a minute. This slide just tells us again the same thing, that if you add the same number to each side of an equation, the two sides remain equal and balanced. So we're going to try using the addition and subtraction properties of equality to solve these equations, right? We'll do the first one together, and then I'll give you a few minutes to try the rest on your own, and we'll ask for volunteers to share their answers and solve the problems along with us, and you can check your work. All right, so first together we'll solve x minus 2 equals 6. We want x by itself. Right now we're subtracting 2 from x. So to undo that subtraction, we need the inverse operation. We want to add 2, right? Because x minus 2 plus 2 gives us x by itself. Well, we added 2 to the left side of our scale, right? If we had a scale, we added 2 to the left side. So now we have to add 2 to the right side so that our scale stays in balance. 6 plus 2 is 8. So we've solved x equals 8, and we can check our work here, right? X minus 2 equals 6. If we substitute 8 for x, is this equation true? Is 8 minus 2 equal to 6? Yes, 8 minus 2 is 6. 6 equals 6, so that checks out. All right, on your own, I'd like you to try 26 equals 11 plus x. X plus 2 equals 9, and 15 minus x equals 20. Our goal is to find the value of x using these addition and subtraction properties of equality to keep our equation balanced so that both sides remain equal to each other, but we get x by itself on one of the sides.